Sip na yun, Hub.
Hi there, welcome to another episode of our series on limits. This time we're going to discuss the different properties of limits. The following properties that we're going to discuss are important because we may use these properties to compute for a limit without even graphing the given function. So these are really important for us to compute easier.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
The first property that we have here is called the limit of a constant. And according to the property, if the function is just a constant function, the limit is the same as the constant. Let us provide some example. The number c that you see here is an arbitrary constant. We see that as x approaches any number a, the answer is always that particular constant. For instance, the limit of a constant, say 4, as x approaches -1 maybe, is equal to the same constant 4. Another example, the limit of pi. What is pi? Pi is just a constant. As x approaches to, say, 1/2, it doesn't matter what x approaches because our function here is just a very simple constant. Our answer is the same constant. That is our first property. The second property, if we are evaluating the limit of a function, but the function f of x is multiplied to a constant, what we can do is factor out the constant and just compute the limit of the function. We see here that in our original limit, c is part of the function. If we factor it out, put it outside, they are equal. Let's provide an example. Say we have the limit of 4, that is our constant, multiplied to another function, say x squared plus 2x plus 1. As x approaches, say, 3, this is the same as factoring out 4 and just focus on computing the limit of the function x squared plus 2x plus 1 as x approaches the same number, that is 3. That's the property that we are discussing here. Limit of a sum or difference of 2 or more, if we extend that, or more functions. This property is telling us that we can actually break this sum or difference into bits of limits. So we can solve the limit of f of x, we can solve the limit of g of x, and the result, we add or subtract them depending on the operation here. Let's provide an example. Let's go back to that function we presented in the second property, that is x squared plus 2x plus 1 as x approaches 3. The function here is a sum or difference. It's a polynomial, actually. It has 3 terms. According to the property, we can separate them as 3 different limits. The first limit involves the first term, the second limit involves the second term, and the third limit involves the third term. We may write limit of x squared as x approaches 3 plus the limit of 2x as x approaches still 3, and then plus, we are following the sign, limit of 1 as x approaches 3. That is how we apply the third property. The fourth property, it involves a product of 2 or more functions. This property is also telling us that the limit of a product is the product of the limits for each factor that we have here. This is applicable if the function that we are dealing is a product. The operation involved is multiplication. Let's have an example. Say we are to solve for the limit of x squared times x cubed plus 1 times, say, square root of x minus 2. This is a product. It's composed of 3 factors. X is approaching, say, 1. According to the property, we can break this down into product of smaller limits. The first limit is the limit of the first factor, x squared. X is approaching 1 times the limit of the second factor, x cubed, plus 1 as x approaches 1. And then lastly, the limit of square root of x minus 2 as x approaches 1. There we have it, the fourth property. The fifth property, this is applicable if we are computing or solving for the limit of a quotient or a ratio of 2 functions, f of x and g of x. According to the property, this is the same as the limit of the numerator divided by the limit of the denominator. For instance, if we have limit of x over x plus 2 as x approaches, say, negative 1, this can be broken down as the limit of the numerator, that is x, as x approaches negative 1, over the limit of the entire denominator, x plus 2, as x approaches negative 1. The limit of a power. According to this property, if we are evaluating the limit of a function, but that function is raised to a particular power n, that is the same as getting first the limit of the function, disregarding the power first. So just take the limit first, and whatever the result, that's the time we raise it with the power n. So that the limit of x squared plus 2, this is our function, but the entire function is raised to a power, say, 10, as x approaches pi. This is the same as taking first the limit of x squared plus 2, disregard first the power as x approaches pi. After solving that, that's the time we raise it to the power 10. That's the power property for limits. Let's provide another example. How do we apply this property if we have the limit of, this time, cube root is a radical expression of x squared plus 2 as x approaches 4, say. Remember that this expression here can be expressed as a power so that we can use this property. How do we do that? We may write first limit of x squared plus 2. Remember that cube root of a particular number is that number raised to a fractional exponent, that is 1/3 as x approaches 4. And there we can see the power. If we apply this property, we may write the limit of x squared plus 2 as x approaches 4. The result, we raise it to the power 1/3. Or also, we may write cube root of the limit of x squared plus 2 as x approaches 4. We are now down to the seventh property, the limit of the single term polynomial x. This is very simple. If we have this polynomial x, the answer is just that number that x approaches 2. If we have the limit of, let's use another variable, say y, and y is approaching 0, what is the answer? It's just that number that y approaches 2, because this is just a single term polynomial. So the answer is 0. Limit of z as z approaches pi, this is a single term polynomial, so that the answer is pi. Limit of w as w approaches a plus b, doesn't matter really, this is a single term polynomial. The answer is whatever w is approaching 2, so that is a plus b. Our last property is actually a combination of the sixth and the seventh property. That's the limit of a single term polynomial, but this time it's raised to a particular power. According to the property, the answer is just that number that x approaches 2, but we raise it to that particular power. So how do we answer the limit of, say, x cubed as x approaches 2? This is the same as, so this is the value of a, it's the same as 2 raised to 3. So it's like we substituted 2 to that expression x cubed, that is equal to 8. There we have it, our different limit properties. In the next video, we're going to apply them. Kindly click on the link above to go to that video.